Hand claps for Ben Wilson.
Thanks, Brian. So, day two, if day one was about Kubernetes, ECS, hot code deployment, how will you take an Elixir application and actually like get it out there and get it running in that sense of production? This is a little bit more about the nature or characteristics of that program itself. It's a combination of kind of some lessons learned from my time at CargoSense. We've been using Elixir in production since 2013. And we've done what I think a lot of people have done, which is they had a Rails app, and then they started doing some stuff in Elixir, and then they moved that to Elixir. And when they did so, they now have an Elixir app that is still kind of thinks in the mindset a lot of where it came from, Rails. But I think this is true of even a lot of applications that have been built sort of new since and not migrated from Rails, because a lot of us are still doing, in many ways, the same kind of thing. You've got your database that you're storing your state in, and you've got your API, often a REST API, that you're exposing information to. And what I'm going to argue is that the way that we use these tools really narrows our thinking about how to solve problems, where we really focus on things and we lose track of activity. And I think this is a big shame because the VM that we have is really good at activity. This is a visualization of a set of processes and the messages that pass between them. It's a visual Elixir. It's a really cool library. The Beam has, all of these individual, processes that are running, and each of these things is, in many ways, the ideal platform for handling activity. What I have in mind with activity is when you start your application, it's really easy to think of it as like, okay, I'm just trying to get anything stored and then visualized on a page. But over time, as you start working with your business, there's parts of your application in particular that have a sort of complex process associated with it. And someone will do something, and you need to handle that, and then they do something else. It's a notion of events. And so events are often a really good way to describe a business process, but usually we don't when it actually comes to our code. This is in part because when you hear event-driven, you're probably thinking oh boy, he's going to try to get me to use event sourcing, and I looked at that, and it looks really complicated, and there's all these frameworks, and ugh. We did that. We looked at event sourcing, and we used the framework, and it was hard. And that was on a new project. If you're trying to retrofit this into an existing project, it's very unclear how you would go about that. So I want to talk a little bit about why, despite the fact that the VM we're running on seems so well-tuned for activity, events, reactions, etc., we don't tend to write code that way. But also, I really want to provide some concrete lessons and strategies that we've employed that you could employ on code bases you have next week. Or if you're starting a new project, that this could influence the very next pull request you make. It will also include a thing that we are trying out. It's an idea that we've had relatively recently and that we're in the middle of kind of developing. And you get kind of a sneak preview of it, and hopefully it'll come out shortly. So with those, though, I think that without making any major changes to your code, you really can be capturing activity right now. But before we get to those, it's very important that we're all on board with why we care about activity and what I have in mind. So let's look at that first. If you can sometime, listen to programmers talk about their programs, but if you turn off the part of your brain that is, I understand programming, and then just listen. And it's a little funny. Part of the funniness, of course, is that we have a whole bunch of jargon that includes words that don't mean what they normally mean. Elixir does not mean Elixir. Ecto does not mean Ecto, and who the heck knows what a Kubernetes is. These are strange words. But the real weirdness, I think, has to do with the relative frequency of our nouns versus our verbs. I was talking to one of our salespeople, and I heard myself say the sentence, we create a sensor registration, and then we create a sensor installation, and then after a recording session is inserted, we update the shipment state to complete. And setting aside the bit where clearly I'm not good at talking to salespeople, the essence there is there's a whole lot of stuff that I was rendering in terms of nouns that really ought to have been verbs. I should have just said, we register the sensor, then we install it. After the data is recorded, we complete the shipment. Why do we talk that way? And maybe this is just me, but I don't actually think I'm all that weird. This is the minute you get a bunch of programmers together and they're like talking about the domain, they're talking about the entity diagrams. It's like the stuff of their application, not the activity of it. So it's kind of easy. I think it's easy to see why we do this, though, because all of our tools do. At the database level, you have select, update, insert, delete. At the API level, a similar set of verbs. And, you know, in theory, your code in the middle there can be whatever you want, but it often isn't, because especially when you get going, like I said, you're just happy to get anything working. And if you get it working, you got to be using those verbs, and so you just copy them up into your code. Who remembers this sort of thing, right? And even if you never actually did this, this isn't bad per se. Like I ran this first in I think like 2005, and it was awesome because suddenly I could have a web page or an API that would like create products, was I think like the original Rails book use case or whatever. And it made it really easy. It made it easy because it answered or provided an answer for one of programming's hardest questions, which is, where does my code go? And it provided an answer like, hey, there's like 4 verbs we really care about at the API layer, and these kind of correspond to certain database operations. You just organize all your code around that, and you'll always just like have a place to put things, and then voila, you can store whatever you want. This isn't always the wrong answer, but the problem is there's another major programming problem we often find ourselves needing to solve. Oh, wait, not that one. That one. So why do we spend so much time talking about naming things? If you look at that first problem, cache invalidation, what are our strategies? We usually, if you can, your best strategy is to avoid the problem entirely. Like, don't use a cache. Problem solved. Your other option, though, is like you use caching strategies where you're always moving to new keys instead of having to like invalidate existing keys and so on. We have techniques. For the second problem, there are 2 known strategies, at least as far as I know. Be good at naming things, don't be bad at naming things. If this is, because you can't avoid it, right? Like at a minimum, you got to talk to your other programmers about stuff. The moment you have more than one thing, you have to get beyond, oh, that thing. You need names. And this is particularly important when talking to stakeholders and whatever it is you're trying to accomplish. So if this is our strategy, we maybe should be pushing back more against tools that limit the valid space of names at our disposal to just nouns. You might be thinking I'm overstating this a little bit. Sensor installation is more awkward than install sensor or sensor installed, but arguably they all kind of carry the same underlying meaning. But the issue with working with nouns is that it really pushes us towards viewing a system in terms of an entity diagram. So to pick some stuff out of the cargo sense domain, a shipment has a bunch of containers, which have a bunch of sensor installations. Each sensor's got a sensor, and they got recording sessions, and there's like a gazillion other things that we could add here. And this kind of gives you like a sense of like, oh, when cargo sense is talking about a shipment, they're really interested in like data. They're interested in like validating that data, and they're going to create some reports about it. And that's fine. Like that's a valid picture of what we do. But what it doesn't tell you is how does any of this actually happen? How does this come about? What's the order of operations here? There's absolutely nothing there to tell you this. And you can't solve that. This is not just because like I'm bad at diagramming. This is because even if you take a subset of that and you just sort of like stick them in some kind of order, this doesn't tell you what's going on. Whereas if you talk about the activity that would lead to one of these things being important, it becomes a little bit clearer. So that's sensible enough. Hey, when we're talking about a shipment, it has a provisioning step. Interesting, that sounds different than, like, it's not going at that point, right? Then we install the sensor, and then you actually start the shipment. So what we're going to be covering, I think this stuff is really important. I think that if you don't capture this stuff, you are doomed to write programs that will, I think, diverge from what the people in your business are actually doing. And the reason is that you create these entities because your business is trying to do this stuff. And if your program doesn't know of or care about this stuff, then as the business changes its activity, these things will just get out of date. And it's easy to miss that. So we first started knowing this when we started working with Absinthe, which is the GraphQL implementation that we wrote for Elixir. GraphQL replaces the traditional REST endpoints and verbs. And so anytime you want to make a change in Absinthe, of any kind, like I'm going to do something that will create a record, I will do something that will update an existing record, it categorizes all of those as mutations. So when we first started writing, we would do a mutation that kind of looked like this. So mutation fields, by the way, so this create sensor installation is what's called a field. It takes some arguments, which I've elided with the little triple dot, and then under that, it returns some kind of data structure that represents, like, okay, the sensor installation's been created. What do you want to know based on the fact that that's happened? Create sensor installation is a function. It's a function that takes a certain input and provides a certain output, where that output is relevant. It's a place to get going on whatever the consequence of that action was. It's not a resource. And so when we started doing this, it didn't take terribly long before we were like, really, we should just do this. Like, that seems clearer. But when we did this, what immediately stood out was all of the places internally in our code that said create sensor installation. Like, I made that change, and I went to my resolver, and I was like, oh, cool, I'll just like change create sensor installation to install sensor, great, and then I just like, I wonder how many other places I say create sensor installation. It's all over the place. Our context functions, our business logic, jobs, etc. And what was really weird is it was often lying. And by that I mean, once the business, once a program gets to any real level of complexity, installing a sensor would also sometimes create a container, or like other things. Logically, what it was doing was installing a sensor in a shipment, which sometimes involves creating a bunch of other stuff. Create sensor installation was a bad name. And so this leads me to the first concrete thing you really could be doing in your code right now, which is writing activity-oriented code. Specifically, what I have in mind is, especially if you're using Phoenix context or anything that sort of amounts to an equivalent of that, try to name the public API of those modules after either something you want to do, like install a sensor, or something that has happened that you now need to deal with, like data received. Have those functions track the activity of your organization. You're still going to need some create functions, because at the end of the day, we do actually have to put a shipment in the database. We have to actually write a sensor installation. But we've actually really tried to make those def-p, right, private functions for that module that really just exist as like a common area to run a change set and some other validations. So as our time went on with our GraphQL API, we kind of took things a step further and increasingly moved to stuff like this, monitor truck, or track cargo, with internal functions that looked similar. And you might say, well, this is sort of apples and oranges. These are two completely separate things. And yes, true. But it's kind of crazy how much stuff creeps into your CRUD functions if you let them. So we had a bunch of logic, for example, that would check and see, hey, what we're creating a sensor installation. This includes information about like what palette it's on. And then we had code in there that was like, oh, well, if the palette has this kind of stuff in it, then we need to go email the customer. Or if it's got this other kind of stuff in it, we have to hit this external API. When we moved to this kind of API, we started writing these kinds of internal functions. And then you could move all of that, you could get rid of all the conditional logic that was trying to like look at the state of the sort of like attributes of this complicated, set of tables, and just be like, when tracking cargo, you notify the customer. It was really transformative for both, not just like how we named stuff and whether that like communicated better, but it actually literally like we could write. You might think this might make you write more code because you're gonna have like different scenarios. We wrote less code because the code could do fewer things, and conditionals are what end up taking up a lot of space, taking up a lot of mental space because you have to track the complexity. So the other thing that GraphQL provides is what's called a subscription. And this is something we'd hear all the time at like conferences or at like training sessions. Subscriptions are really cool. What they do is when you submit a subscription query, instead of running it immediately, instead the server holds on to it, and then when something happens in the system, it runs that query and pushes the result to whatever user asked for it. What we hear all the time is that people thought this was awesome sounding, but they had a really hard time figuring out how to subscribe to the things that they cared about. So they would show me a subscription that would sort of look like this. Like, hey, we want to know when there's an update to a shipment that contains this kind of crap, and it's now in this kind of state. What this was telling me was their system has no sense of what events happen in their system, right? They're just like moving data around, but they never bothered to put any label on the significance, the intent, the consequence of that movement. What you want to be able to do is write something like this. And so doing this, though, requires that your system, at least in its code, have some kind of notion of events. If you have that function we had earlier, cargo tracked, you can see how you would just put a like publish this, and then that would hit Phoenix pub sub and push it out. So where possible, the other concrete thing I'm going to suggest is use activity-oriented APIs. If you're not using GraphQL, come up with some other way to do that. That's not my job to tell you how to do that. But I actually think this is a lot more possible than people tend to think. And at a minimum, hand off as quickly as possible the parameters from that API to something that means something, because this problem gets a lot easier if you're not being squished on both sides by this sort of really limited vocabulary of verbiage. So looking at this, though, maybe you can't change your GraphQL API, and this is maybe where you're fearing that I'm going to tell you to do something insane with your database. I'm not going to do that, but I do think that that is an obvious place to look. It's really easy to think of the only way we sort of ultimately manage the database as creating, inserting, updating, and deleting our things. But there's actually a whole other category of information that we could be managing there that might make this easier if you can't do anything about your API. So if we revisit the flow we had earlier, right? Register sensor, provision sensor, install sensor, start shipment. There's a natural sort of past tense version of each of these things that would represent that this in fact occurred. The idea is that what you can capture that kind of stuff in your database too. And now what you're doing is not only is your code beginning to read or treat events and activity as a first-class sort of organizing and naming principle, you can treat it as a first-class data principle as well. And this will make an enormous difference for how you reason about what you're doing. Now, I'm not talking about an audit log. It's the easiest thing you might think of is like, oh, cool, I'm sold, Ben, I'm going to do this. Like, I'm going to just go to that cargo track cargo function, and then like at the end, I'll be like, and also tell the database I tracked cargo. The problem is when you're doing an audit log, all you're just saying is like, I did this. What I'm going to suggest you should do is event sourcing, or something that's a whole lot like event sourcing. And the idea with event sourcing is that when you want to do something, when you want to take an action, you do whatever logic you need to do to say, am I allowed to do this? Can this happen? And if you can, then you cut the event. And then all the logic afterward, inserting shipments, updating your tables, takes the event as input. What's great about this is that it guarantees that the event contains everything you need to know. Everything that all the decisions that your application is making are based on this artifact that then you, the developer, can go look at. You didn't like, oh shoot, when our audit log, we forgot to include this piece of info, now I don't know what's going on. Like, if you don't include the info, it won't work. Your tests will ensure that, or even just clicking through your app will ensure that that information is there. Now, some of you are looking a little concerned that I'm lying about my earlier promises because I said that this is something you can do next week, and event sourcing is not something that you can do next week, certainly not from a whole framework. But good news, everyone. The essence of event sourcing is a lot easier to get to, I think, than you might otherwise believe. So this is where we get into something that CargoSense is kind of trying out. What I'm showing you is if you're feeling particularly adventurous, I don't think it's terribly complicated, but there's some nuances here that we're going to probably try to wrap up in a little library for everyone to be able to consume and use more easily. But so if we're not trying to create an event log, or rather, I think the best way to get going is to not try to create an event log for your entire application. For us, at least, we had various bits of information that were not as important very little movement happened around them. Shipments, that's where all the craziness was. And so the most important thing for us is that we understood the sequence of activities around shipments. And so what I would recommend is create an event log for shipments. This is relatively easy to do if you keep it kind of narrow in scope. So the shipment events table itself just needs to have a column pointing to the shipment. A field type, which will be the sort of type of event it is, sensor installed, data received, that kind of thing. And then a sort of JSON-B column for the stuff that you'll use. I'm aligning a couple details here. Your data thing, we were trying to do some techniques around actually making that more structured so that it's not a totally opaque, could be random JSON details. And then on your shipment table, what you're going to want is obviously the reverse association so that you can grab events easily, but then also a last event ID, and this will be very important. So before we go further, it's really important that we are clear on the two characteristics our system needs to have to make event sourcing work. One is somewhere to put events. Two has to do with how you process those events. For a given thing, in our case a shipment, we need to be absolutely sure that we handle events one at a time. Otherwise, we're going to get conflicts. Maybe we're trying to remove a sensor simultaneous to data coming in for it. Which happened first? Are we going to create a report for a sensor that's not even on that shipment anymore? Like, those are not outcomes we want. The natural way to handle this, we're on the beam, is an Elixir process. But if we took anything away from Paul's talk yesterday, it's that coordinating work on a cluster of processes is not a trivial problem. And it's not trivial if you're starting with a brand new application, and it is impossible if you're working on a 3-year-old CRUD-driven application you ported from Rails. It's not going to happen. I want to get there. I think parts of CargoSense will get there. But the goal here is to provide meaningful steps along the way that kind of set us up for success when tooling around that kind of thing comes around. So here we have our way to track events, and then a little ecto query to make sure we can update the event. So If you're not super familiar with Ecto, the details here don't terribly matter all that much. Down here, we've got a little function that will grab the biggest ID for all the events that belong to this particular shipment. And then the first function is creates an Ecto query or an SQL query that will update our last seen ID to whatever that value is. So how do we get this serializability? So if we can't reach for processes, what other tools are at hand? The database. So Postgres is something you're already using. You're probably already using Postgres transactions. I really hope you are. And Postgres transactions have the neat feature where you can tell them to be serializable. Now, before any of you get too terribly alarmed, there used to be, a long time ago, and certainly on other databases, significant performance issues with serializable transactions. You might imagine that the easiest way to do serializable transactions is to do literally just one of them at a time. There you go, one after the other. This is, of course, horrible for performance. So Postgres, being awesome, doesn't do that. And instead, what Postgres will do is it will run multiple serializable transactions simultaneously with then a little bit of tracking metadata to figure out when there would be a conflict. And this is what we want, right? Like if we get data for shipment A and we get data for shipment B, that should process in parallel. That's what we want. That would be awesome. But if we get two different things for the same shipment, we want to be able to reason about that in sequence. You can try to engineer your own version of this with optimistic locks or with pessimistic locks, but other than the fact that those might be more familiar to you, I actually don't recommend that at all. Postgres is really good at this. It's got a bunch of neat guarantees. If you have two transactions that are running and then they conflict, because of the way Postgres tracks the nature of that conflict, it will choose the transaction. It's got to pick one to kill, right? So that you have to retry. The one it picks will have the highest likelihood of being able to succeed if immediately retried. So this is great. You don't have to do any of this stuff for yourself. Why do more work than you need to? Frankly, many of you should already be using this. If you are doing something based on a user uploading a file or hitting a button or whatever, and you're doing multiple tables, odds are good you already have race conditions in your code that you just haven't run into or haven't noticed yet if you're not using this. So performance aside, you're probably going to have to pay for this anyway. Then we should have no fear reaching for this to try to serialize our activity. So how do we do this concretely? At a high level, the approach looks like this. If you're using Ecto multi, you create a new multi. You're going to set the isolation level. You're going to build your event. You'll make any changes you need to other tables based on the event. You'll update your shipment, and then you will run the transaction. For those of you who might be new to Elixir, Ecto multi is a way to compose a data structure that represents all the things you want to do in a transaction. This is really nice, and especially for this kind of use case, because we're going to have some generic logic around setting the isolation level and updating the last event ID that we'll want to sort of extract out. This updating the last event ID bit is super critical, by the way, because although a lot of the operations you're going to be doing based on an event for a shipment they have a high probability of conflicting, because if you're doing something on a shipment, you'll probably hit the same tables. This guarantees it. Like, if two transactions are running and they're going to make a change to a shipment, if both of them try to set this value, it guarantees that they'll conflict, which is what you want, so that you can then be forced to retry one of them. You can also see how you would do this with the standard sort of functional style or function-based repo transaction, right? You have a function, and all that is going to be in your transaction. You set the isolation level, you build the event. Now, there's two things that we need to consider here. One is, normally if you have transactions that can fail right now for one reason or another, usually they're failing for a good reason, where good means they try to do something they shouldn't have. So if you have a transaction that's like inserting some stuff into the database, maybe it fails, and almost always it's going to fail because a data validation wasn't passed, or like a unique constraint was violated or something. Now we have a new category of transaction failure, which is a serialization failure, right? This transaction failed not because it did anything wrong, but because it lost the race. And so we should treat that a little differently. We want to retry that. So the first thing we're going to want is a little helper function that will retry the transaction if it fails. And this helper function is also going to handle tracking like the last updated thing and setting the serializable constraint. So here's the multi version of that. You can see why I'm going to try to create this little library. It's not the worst code in the world, but if you didn't have to write it, that's always better. But the idea is we get a multi. So this is in my app.repo. You can put custom functions there, by the way. It's a module. So we're going to call it serialize. It takes whatever multi we're working with. It takes the shipment. This is the thing we're serializing around. And then we need to prepend this set transaction isolation level directive. This has to come first in your transaction. If you make any changes and then try to run this, Postgres will be like, nope, can't do that. It's too late. So, and then we also handle updating the shipment so that we guarantee. This is a two-clause function, one for handling multis, one for handling the function style. And it's the same thing, right? Run, we're going to wrap. We get this function that is, which would be the equivalent of this guy, right? So that's our first argument here. And we call that there on the fourth line down. But before it, we set the transaction level. After it, we update the shipment, and then we return the results. The do serialize will handle retries. So we try to run the transaction, and if it fails with a specific kind of PostgreSQL error, then we'll retry up to 10 times. So just to be clear on how all these retries are going to work, events are happening in your system sort of one of two ways if it looks a lot like ours, and in talking to people, it often does. You have an HTTP API that is doing writes, and then you have like asynchronous jobs. And so 10 here can be tweaked, but the idea is for a given HTTP request, it gets 10 attempts to immediately retry. And if it can't, it'll just fail, and the user can like retry. This all happened in a transaction. It's just like a normal transaction failure. The only reason this isn't going to work is because your system is essentially overloaded. You're doing so much around that it can't actually provide any guarantees. This is exactly the time you do want it to fail. If you're running transactions right now and they're succeeding anyway, that's because you're going to have the race conditions. So much is happening, you can't really keep track of it. Failure is the right option there. Failure is the right option for a job too, by the way. Like, give it a back off, let it retry in a minute, 5 minutes, whatever. So that's the idea. And then if it's any error that isn't a serialization failure, it's like genuinely bad and it's dead. So what this gets us to is this much simpler framework. So you start a struct, or you start a transaction, and then you make changes from it, and then you serialize it. Some of you might be kind of worried that you're now going to have to go rewrite all of this complicated business logic you have in multi. And that was certainly like my concern when I was starting to do this. Fortunately, we don't really need to do that. The goal is not to change really much of your code at all. If you're like us, you're going to want to be able to do this incrementally, one sort of sprint at a time, and doing serious reworks to all your core. This is often the most complicated part of your app. Like you can only stand so much churn there. So let's look at what this does concretely for a little example from CargoSense. So these two functions happen in a job that processes a file of data. We get a data file in. We need to actually load all that data into the database so we can actually look at it, figure out what span of time it covers, et cetera. And then based on that, we need to go figure out what shipment is this for. One of the things we'd hoped really early on in CargoSense is that people always uploaded data for the most recent shipment. This is wildly false. They would just forget about sensors for months and then, hey, here's this data. Figure out where it goes. I don't have to tell you. Just figure it out. So some complicated logic there. So we try to find the sensor installation, the shipment that data is for. Session here is what we call a recording session. It's a span of time for which we have data. So after we figure out which sensor installation it is for, we can then associate the two. The idea is that you can simply, instead of changing any of those functions, you just change how they're called. So you wrap it in a serialized call, you do your finding logic, and then before you associate the sensor installation data, you cut a data received event. This little function is creating one of our little shipment activity structs. It's a data received type, it's got the shipment ID, and a little bit of information. So the idea here is we took, and then the associate sensor installation function for us was, it's just a local function, and so we could pull the data right out of the event. If you needed to, you could just bind the event to a variable and yank stuff out. The point here is you're not changing how the functions work, you're just changing how you call them. You make sure to call them in a serialized transaction, and you make sure that the data that you're passing to it is exclusively from the event itself. The function can just carry on doing what it was doing. But this starts to feel, this is where things get really interesting, right? You might worry, if you just back to here, like, okay, great. That doesn't feel very event-sourced. Congrats, I just added a layer of indirection to all of my function calls. I get that I get an event log now, that's good, but The point is, now that you have split, you're starting to build this line in your code between things that happen and things that need to therefore happen, right? Happen as a consequence of it. And so this is you can have this handle event call, pattern match on the type, and there you associate your sensor installation. And oh, by the way, now that we have more data, we need to go redraw all of our graphs. So this is really powerful. We have this log in the database, and we're now driving activity based on that data. So this is the third takeaway that I think will apply to a lot of your projects, and we're going to hope to try to release a library to make easier for. The thing about this is you don't need to make that many changes. You don't need to involve distributed processes. You don't need to get any new fancy tooling. You're not even getting rid of Postgres. Rather, you're just changing how you use it a little bit. You're treating all the tables you already have but also capturing the activity. And if you can do all of these things, then you can start thinking about the activity of your applications at all the layers of your API, all the layers of your program. Your entire system can adapt as the flows of your business users change. If you don't do this, it's the tools that we've been handed make the default way of going about stuff really limited. If you use just the generated code, if you use just the sort of verbs that get handed to you, you're going to miss out on, I think, what is the most important part of any complex application. If you ask someone about their job, they're going to tell you what they do, not the contents of their file cabinet. Thanks.
All right. Thanks, Ben. Do we have any questions? Oh, okay. I'm going to hit them, and then I'm going to get you.
This is on, right?
Yep.
Okay, sounds weird. As you were implementing this or changing some of these practices, did you happen to notice or collect any sort of measurable data, I guess? Did you notice reviews were easier or onboarding was easier or, general kind of catch-all improvements because of some of these design decisions to go through?
Yeah, that's a really good question. I can give a kind of answer, but I wish I could give one that was more directly at your question. And that's simply because we're a really small team at CargoSense, and so I haven't had to do an onboarding in a while. However, what I can say is this. There's a lot of code that we write and has worked for a while that I then did this refactor and then ignored for a while. And then someone was like, hey, how does that work again? I could go back to the code and answer that question much more easily. Previously, it was then what does this function do to the database? Then what does this function do to the database? And whereas at a high level, I could be aha, when we try to do these kinds of things, we get this kind of output, and then these are that triggers these following sequences. Specifically around, we have a lot of work that happens around doing post-analysis to data and shipments, report generation, and excursion analysis, et cetera. Those have dependencies in time on one another, but some of them are sort of separate systems. So we track flights, for example. We have a separate system that hits an API and keeps us up to date on what flights exist. It's really important when we're generating flights or reports that we include up-to-date flight information. We're going to do all kinds of terrible hacks to try to make sure that the asynchronous job that generates the report is able to figure out if we have up-to-date flight info. And as we've started to implement these kinds of designs, a lot of those questions get much easier to answer in the code. It's not exactly the question you asked, but to some extent, we aren't in a situation that's easy to answer concretely, and I don't want to make something up. So.
Great talk.
Thanks.
I have a question revolving around the last event ID and the fact that you're storing that in the actual shipment. What's the thought behind storing that in the shipment versus querying for it?
Good question. Yeah, so you're pointing out that because of how I'm going to use this opportunity to segue slightly into an interesting property of the transactions you use versus serializable transactions. So in the transactions you use, if you were to just do a normal transaction, you say, hey, give me the count of all events on this shipment. And then you'll get 10, right? And then you wait a second, and you do that same query. You might get 11. Other transactions are allowed to commit in the middle of you doing stuff, and the default is that you can't read. It's a read committed is the default, and that means that you're not going to see anything that a transaction is in the middle of doing, but once that other transaction commits, it will affect what you see. Serializable guarantees repeatable reads. So if you were to simply ask for what is the biggest ID at the end of your transaction, that would also conflict with any other transaction that was trying to insert events. I put that on there as much for debugging and being aware of where your app is at than anything else. It is critical to ask about what is the current event. It's not critical to store it, but I think it's useful to store it.
Okay, thank you.
I'm just trying to get a better sense for the high level reason behind this, and I think the thing that stood out to me the most was when he said this function is line. It's not that it wasn't doing that thing, it's just that there were some side effects involved in it. So is this just a better way of kind of dealing with those side effects?
Yeah, good question. Because when I said that, I imagined someone might respond, well, if it's lying, that's your fault. You wrote it, right? So just make it do fewer things, if it's doing a bunch of stuff, extract that, have it create container, all those extra CRUD functions. But in practice, the reason it was doing them wasn't a bad reason. It was doing it because it was part of a flow. It was just badly named, and that's a decision you have to make in your app. Is this function doing too many things, and if so, is that because it's actually doing too many things, and we need to be able to break them apart so we can compose them differently, or is it doing all those things because it needs to compose them to really accomplish what it's trying to accomplish, and I just didn't name it after what it's trying to accomplish. And so, especially at the top level API functions for API here being like your code's API, it ought to read like things that you try to do with shipments, not things you do to the shipments table. And that really is two completely separate things. Did that answer your question? Yeah. Great.
Cool. Well, thanks again, Ben.
Great, thank you.